Okay, guys, so first up is going to be group 11 for the IMDb project. Now, what I'm going to do is I'm going to give you control over this meeting, and then you can take it and start presenting, okay? All right, so let me go ahead and do that. Let's see. Let me get all of your group members here. Okay, so Ahmet, Dokan. Ahmet. Dokan. Saeed. One more Volkan. Okay. If I'm not mistaken, all of your group members should be now presenters and should be able to take control of the presentation.
Thanks, sir. Just a minute. Okay, can you hear me, guys?
I can hear you just fine.
Yes.
Okay. Ladies and gentlemen, welcome to IMDb Lite app and database presents. I am Said, who is the team leader of Group 11. The presentation will proceed as follows. Introduction, where did our data supply? Which technology that we used? Introduction of our database structure, backend queries and process, what's API and how we used, introduction of iOS app and questions. First of all, I want to give some information about our project. IMDb Lite is a project that can help to choose movie and series to watch and also give information with detail about series and movies. We work with teams who is Volkan, Erinç, Doğukan, Ahmet and me as Said. Now Erinç will be with you.
Thank you, Said. So, why we brought a new version to IMDb? As a result of our field research, we found that the 95% of the daily users use only a very small number of data provided by IMDb. We also find that these details make it difficult to use. With IMDb Lite, you will find the data you want in a simpler and faster way. As a result, IMDb Lite gives you up to 40% ease of use in daily use. But how? That's thanks to IMDb, they allowed us to use their data. So we receive our data daily from IMDb's updated dataset. By using the technologies that Doğukan will explain soon, our data transforms the data that users need more. And we present these data to our users in simple and faster way.
Okay, now I want to give you some small informations about tech we used in our project. Let's look. GitHub. GitHub is a website and cloud-based service that helps developers store and manage their code, as well as track and control changes to their code. Microsoft Azure. Azure is a public cloud computing platform that can be used for services such as analytics, virtual computing, storage, networking, and much more. It can be used to replace or supplement your on-premise servers. Why Azure? Because it's flexible, open, reliable, global, and economical. PostgreSQL. PostgreSQL is a powerful open-source object relational database system that uses and extends the SQL language combined with many features that safely store and scale the most complicated data workloads. Why PostgreSQL? Because it's free. Python Scraper. So, what is web scraping? Web scraping is used to collect large information from websites. We did this web scraping with using Python. Why Python for web scraping? Because it's easy of use, large collection of libraries, dynamically typed, easily understandable syntax, small code, large task, and community. REST API. A RESTful API is an application program interface that uses HTTP requests to get, put, post, and delete data. Why REST API? Due to its scalability. This protocol stands out due to its scalability. Thus, to the separation between client and server, the product may be scaled by a development team without much difficulty. Due to its flexibility and portability, it is possible to perform a migration from one server to another or carry out changes on the database at any time. Front and back can therefore be hosted on different servers, which is significantly management advantage. Entity Framework. Entity Framework is an object relational mapping framework. It's an enhancement to ADO.NET that gives developers an automated mechanism for accessing and storing the data in the database. Alamo Fire. Alamo Fire is a Swift-based HTTP networking library for iOS and macOS. It provides an elegant interface on top of Apple's foundation networking stack that simplifies a number of common networking tasks. And lastly, Swift. Swift is a powerful and intuitive programming language for macOS, iOS, watchOS, tvOS, and beyond.
Now I am going to talk about unnormalized form of our database. In our project, we have two types of shows. We have TV series and we have movie. And we have a bunch of details about them. We have genres, start year, runtime minutes, average rating. And if it is TV series, we have season number and episode number. And we have some people who is working on these movies and TV series, such as director, writer, and actor. And we have the detail of these people, such as name, birth year, death year, and known for. I'm not going to be able to show you the normalized form of our database because we have a lot of tables. That's why I'm going to show you the entity relationship diagrams which we draw from our normalized form. First of all, I want to explain why do we have TV series and movie? Why didn't we have one table for both of them? So as you can see, we have the same attributes for both of them. But if we have a TV series, we are going to have this information for each episode. So if we had a one table, we were going to have this detail for TV series, TV episode, and movie. And it wouldn't be a good way to keep our database. Now look at our relationships. I'm going to start with movie. As you can see, we have many-to-many relationship with character, person, genre, language. And one side is mandatory and one side is optional. And how can we read this? For example, if we have a movie, we have to have person. We are going to have writer, director, and actor. But if we have a person, it doesn't have to be in the movie table. It is the same with genre and language. If we have a movie, we have to have genre. Or if we have a movie, we have to have platform. But if we have platform, it doesn't have to be in movie. So let's look at the TV series. In TV series, we are going to have more than one season. We have to have at least one season, but it might be more than one. But it is mandatory because every TV series has to be a season. And season has to be episode. It at least has to be one episode. It might be more than one. And it is the same relation with movie. Like we have many-to-many relationship with person, genre, language, and one side is mandatory, one side is optional. If we have a person, it might be in episode, but it doesn't have to be. So basically, this is how relationship looks like.
to talk about the backend side of our project, which we developed with API-first approach. Well, on the framework side, at first, we choose to develop our API with JavaScript on Firebase platform because it provides some ease on deploying our app where you don't need to set up a server. But after some progress done, we have changed our mind and we wanted to have full control of our environment. We also changed technologies we used and switched to C#.NET Core. Also, we used Entity Framework, which implements repository pattern. What repository pattern is that is simply used to create an abstraction layer between data access layer and business layer of the application. This technology also provides some ease on designing database. How? Well, actually by not designing it. This is something called code-first approach, where you create domain entities, classes in your code, then generate database by this structure. Sharp also has a technology called link queue. At the code below, you see is how link queue syntax looks like. This link queue code does the same thing with the query at the top. But here, I'm going to stick with the original SQL query for demonstrating this stuff. By the way, I also took these queries from the log file of database and refactored them to make it easily readable. So, what this query does is that it gives the movies with the certain genre we asked, and by giving the genre ID. Now, what we see in this slide is part of our first ER diagram on the bottom left and final design of the part on the right. As can be seen from the first diagram, image table has one-to-many relationship, and genre table has many-to-many relationship with the movie. Since movie and genre tables are connected with many-to-many relationship, we implement this by putting a table that shows this relation by only taking movie and genre IDs. So the only feature of this bridge table is that it just keeps track of which movie is related to which genre and vice versa. So what the query at the top does is that it joins image and that bridge table to movie together and filters it by genre ID. Now let's consider the case that we want to fetch movie details. The diagram you see demonstrates that the final shape of JSON data. In here, we won't only get the data points in movie table, but also its locations, genres, countries, keywords, etc. And also the people who participated in the movie, and some character names of these people played. I'm going to explain related queries piece by piece to make it easier to grasp. So in this diagram, I got rid of all irrelevant tables to see only what we needed. First and easiest, getting the movie record is image URL and content rating. Since content rating and image tables have one-to-many relationship with the movie table, we simply join them and then get the movie by given ID. If you look at the query below, you will see how we do this is simply using left join keyword and matching foreign keys in the movie table with the primary ones of others. Now we are getting each table that you see on the left. These tables have many-to-many relationships with the movie, which means, for example, genre may have multiple movies, while movie may also have multiple genres. So we are joining these tables to their bridges and filtering them with the given movie ID. We actually did it in the very first example, but from the opposite side. We filtered movies by their genres. Now here, we are getting each people who participated in the movie, except actors. I want to point out that there are 3 tables used to create many-to-many relationships between person and movie tables. You may ask that, why there are 2 different tables since they are almost the same? Why is that is that these are not only stating the relations between movie and the person, but also they are specifying what kind of relation the person has with this movie. So we come up with this idea of this method rather than just reserving another attribute in the relation. The query to get these records are almost the same with the previous ones, in addition to using left join for people's image URLs. Now we are getting actors. In this query, there are 2 different key factors with queries 1 before. First, we are keeping importance information in relation because we want to show the big stars on top. Well, second one is that we are also getting which characters are played by this person in this movie. In here, we are just simply joining this character into the person. So this is how it looks like in link queue syntax. Some subquery is shown at left and how it's summed up in right. Well, even though this method seems kind of complex, it's not getting better in the next one. The diagram you see shows relevant tables when you want to fetch details of TV series. We are doing the same thing here, although with a small difference. This time we are not fetching all details in TV episodes one by one. Now we are using them as a kind of relationship to get records we needed from the table at right. And also TV episode subquery is used for counting each people's appearances per episode and getting the first and last day part again. The rest of the query is similar to that we use for the movie. Therefore, I'm gonna only show queries where these differences occur. Now, on the left side, we see what the response data is. When we ask for a certain TV series from the API, in this case, whose ID is 1. The query on the right side is a subquery for the data enclosed in brown rectangle, which shows the people who participated as director in this unique TV series. What this query does is that it matches through the TV series to the person and image tables. Then it groups them by person, counts them for each, and gets the days of when these people first and last time participated in this TV series. So this example shows where small differences occur. As you see, we are using season and TV episode relations to reach the genres. We are querying them, then taking their distinct. This query on the left side shows what gets executed when we add a new platform. On the right side, we can see how this is performed by entity framework. We are simply creating a new entity, an object, then simply adding it. After save changes method called, the query on the left side gets executed. And this is how we add a relation between record of two tables, which have many relationships. We are simply taking their IDs as foreign keys and putting in the bridge table. So that's all from me. Thanks.
Said, are you there?
I'm sorry. I forgot to open my microphone. Okay. We explained what's API before. Now let's get deeper. API generally work as send request and get response. Also, it gets some parameters for use on queries. In our project, we use API for communicate iOS app and the database. App sends parameters with request and API returns data with JSON form, which is useful and general data form that use all of the world. Let's check some API calls. Root address is the API IP address for reach and use it. Endpoint format is which address or data that you want to reach. Also, this part of API can get parameters and action. Let's check our API calls. In first calls, API returns all gens in our database. As second one is updates and fields on movie, and also that gets movie ID, updated field name, title, and updated value. The last one is remove person from a series, and that gets people ID and person ID and TV series ID. Now let's check our iOS app. Just a second. Can you see the screen?
Yes, we can.
Yes, we can see.
Okay. On the first screen, there are categories that fetched from our database. Also, we can change the view on here as platform and categorize. Let's pick some categorize. Let's select action. In here, you can see the watchable objects, but before the select, we can go to settings. In here, you can sign in or sign up or add platform. in normalized, you can sign up as normal person. But if you want an admin user, you must be send an email to us. And if you want to add platform, you must be an login. Also in here, we use two technology for security on passwords. One is Bcrypt. Bcrypt is crypt our password. The other one is Apple password protocol. These times Apple have the most powerful security protocols. So because of that, we work with Apple on here. Let's log in. We created a user for this. Admin, let's sign, and yes, and get, and let's add platform. The platform name is a trendy Akuzam, www.akuzam.com, and description that we need, guys. And our platform added on our database. Let's get back. In here, you can select and liked and watchable objects. I select Star Wars Episode 5, but first I want to like it and get deeper. In here, you can see some information about the movies, like storyline, duration, language, rating, votes, and etc. There are some other information on our database, but we couldn't show on here. Also on below, you can see the person who is acted in movie. Also, there is an edit mode for just admins. In here, you can activate the edit mode, and if you want, you can change the name or you can edit the language. Let's add in here Turkish and done it and close it, and our language added on here, also on here on database. Let's pick one actor, Harrison Ford, which is trend. In here, you can see the person informations with name and birth date. Also, if death is person death, you can see the death date. Also with image. On below, you can see the watchable object, which actor or director activate. You can go deeper and deeper like this, but not now. Let's pick one TV series. Let's click link. In here, same as the information, same as the movie, but there are small changes. You can see the informations again: storyline, duration, rating, also episode count, and seasons and crew. All crew you can see in here. Also, you can delete the person remove if you are an admin. This angry man deletes this. That's a punishment, and yes. And as you can see, our person is removed on database on here. On the seasons, you can check the seasons and episodes. Let's pick season 6. On here, you can see the episodes, small information, name, duration, and rating. Also, small image. Let's pick Gotcha. On here, it's like a movie page. You can see information, storyline, duration, and platform, if possible. Also, person and person's characters on below, and small image. And our app is like this. Thanks for all hard work, our teams, and thanks for listening to us. Thank you.
Okay, does anybody have any questions? You can type them in or speak them out. Very, very good. Okay, it looks like you got a couple of questions in the chat, so if you want to answer those, go ahead.
Guys,
Göksu, we already pulled it, fetched it in the beginning, so it's in our already in our database.
Muratcan, the answer of question is yes. Why do someone need to be an admin? Because if all users can edit or delete the data, or our data may be deleted completely or changed completely, and this is not our want. Also, yes, we have an backup, or that's updated hour and hour. Also, if our system deactivated, we can fetch our data from the IMDb for a while. Thanks for questions.
Yeah, I have one question too that I want to follow up with. So I noticed that for you to add a language, so in the example you gave, you I think it was Star Wars. Good choice, by the way. You typed in Turkish and it added Turkish to it. What if someone mistypes it? Like, could you have like a drop down for possible languages that have already been used? Because what if somebody misspells the word, misspells the language? Would it add that as a language? Do you understand what I'm saying?
Yes, in our database, there's a language table. If person do some type mistake, we check our database, and if some matching, we add automatically. But if like randomly added the language, if will not be added, it won't be added on our app and database.
All right, cool. Very, very good. All right. If there are no other questions, then we will end your presentation there. Thank you very, very much. And I'm looking at the attendees list, and I noticed that our other two groups are not in attendance. So I guess we will have to meet again on Monday when they will present, and they will have to be considered a day late. Okay. All right. Thank you guys very much. I'll end the recording now, and I'll post this to the Microsoft Stream and to YouTube as soon as it's done processing, so the other people who didn't attend today can view and also comment. Thank you guys very much.